Brain-computer interfaces are rapidly transitioning from medical therapeutics to elite enterprise environments. In 2026, non-invasive neural interfaces optimize how modern executives interact with high-frequency corporate software pipelines completely. According to research published in Nature Machine Intelligence, modern electroencephalography arrays allow seamless cognitive steering. High-velocity corporate environments utilize these non-invasive decoders to bypass traditional manual hardware inputs completely. This structural shift transforms human-machine symbiosis into a directly measurable operational metric. By embedding frameworks like the IEEE Explore technical standards, enterprises deploy neural telemetry to accelerate automated workflows. The primary objective remains maximizing corporate data processing speeds while reducing cognitive friction. Organizations integrating these neural architectures establish a definitive technical advantage, redefining total workforce efficiency and platform execution. However, scaling this architecture introduces massive infrastructure questions regarding data sovereignty. Later in this briefing, we will reveal the exact risk mitigation framework required to protect sensitive corporate cognitive telemetry. To understand the financial implications, executives must differentiate between temporary medical applications and persistent enterprise tools. The current landscape evaluates neural bandwidth as a primary multiplier for cloud compute infrastructure. As generative AI systems advance, the human operator remains the ultimate bottleneck. BCI technology addresses this limitation by establishing a direct, high-bandwidth communication channel between intention and algorithmic execution. This integration directly impacts enterprise OpEx by minimizing the time required to compile complex strategic directives. Leaders leverage neural telemetry to supervise automated swarms executing highly complex, cross-functional workflows. Global tech channels, like at AI Knowledge is Power, track these exponential developments closely. The strategic parameters governing this technology are extensively documented within Global Research Portfolio and GEM Directives 2026. PDF to guide future operational deployments. Let us examine the foundational components that make this cognitive layer functional. This architectural breakdown demonstrates how raw neurological signals transform into precise, machine-readable commands within modern cloud environments. At its core, enterprise BCI relies on advanced signal processing and deep machine learning models. Non-invasive sensors capture voltage fluctuations from the scalp, filtering spurious environmental noise out systematically. These raw microvolt signals are processed using convolutional neural networks optimized for time series data. Data insights from the Vector Institute highlight how deep learning decodes nonlinear cognitive patterns effectively. The algorithmic logic maps specific neural oscillations to defined corporate software actions. For example, focused sensory attention can trigger high-frequency database queries or initiate automated internal system microservices instantly. This process leverages frontier model capabilities highlighted by OpenAI research to anticipate user intent accurately. By analyzing cognitive preparation states, the network initiates back-end resource provisioning before manual confirmation occurs. To maintain operational stability, the architecture utilizes a continuous feedback loop between user and algorithm. The system dynamically recalibrates its decoding matrices based on measured real-world executive performance metrics. Stanford human-centered AI research emphasizes that safety must be embedded within this algorithmic layer. Trustworthy engineering ensures that involuntary neural patterns do not trigger unintended actions across production environments. The integration architecture mirrors standard multimodal inputs, treating brain-computer telemetry as an advanced API endpoint. This telemetry feeds directly into semantic routers that manage complex corporate knowledge graphs seamlessly. From a tokenized economics perspective, reducing the steps between thought and execution optimizes token usage. Highly targeted neural intent limits unnecessary iterations, lowering overall corporate cloud compute overhead substantially. Organizations must evaluate this technology through the lens of long-term digital maturity models. Moving from basic mouse clicks to continuous neural steering represents the ultimate stage of human orchestration. The 2026 benchmark establishes that non-invasive hardware has achieved sufficient signal-to-noise ratios. Elite corporate environments capitalize on this hardware breakthrough to achieve unprecedented operational data processing speeds continuously. This represents a paradigm shift from traditional human-computer interaction models used historically. Executives are no longer passive monitors. They are deeply integrated nodes within modern, unified, autonomous software environments. The technical reality requires robust, low-latency edge computing infrastructure to process telemetry locally. BCI endpoints must execute feature extraction within milliseconds to prevent visible lag during intense corporate operations. This local processing strategy directly aligns with modern enterprise cloud optimization and data governance. Minimizing raw data transmission preserves valuable bandwidth while isolating sensitive biological neural telemetry from external exposure. By analyzing these first principles, tech leaders can design scalable, future-proof operational frameworks. The goal is combining human strategic oversight with the relentless execution speed of enterprise artificial intelligence. Now, let us transition from theoretical mechanics to the actual corporate implementation strategy. Deploying these systems safely across an enterprise requires a highly disciplined, multi-layered architectural roadmap always. Implementing enterprise brain-computer interfaces demands a phased architecture that mitigates initial CapEx risks. Organizations should begin by deploying non-invasive hardware within specialized, high-velocity strategic decision centers immediately. Insights from the MIT Sloan Management Review confirm that successful digital transformations require targeted, complex deployments. For BCI, this means isolating pilot groups like financial quantitative analysts or system administrators. The infrastructure blueprint requires a hybrid cloud architecture to manage the massive data load. Edge devices handle real-time signal classification, while the cloud coordinates large language agentic models efficiently. To resolve the cost dilemma mentioned earlier, companies must establish a strict risk mitigation framework. This framework treats cognitive telemetry through strict data tokenization, separating personal identity from functional commands. By tokenizing neural patterns, the enterprise ensures that raw brainwaves are never stored permanently. This architectural choice radically reduces the risk profile while satisfying global data privacy compliance mandates completely. According to reports by the Capgemini Research Institute, smart infrastructure requires clear performance metrics. Companies must measure BCI integration ROI through tangible variables like task completion, velocity, and system accuracy. When human operators manipulate complex corporate software suites via neural commands, execution latency drops significantly. BCI-driven workflows bypass neuromuscular delays, allowing rapid configuration adjustments across global supply chain networks. IDC market intelligence forecasts indicate that elite enterprise IT spending is shifting toward cognitive amplification. Spending on traditional input peripherals will gradually decline as neural interfaces achieve mainstream commercial scalability. To achieve seamless integration, developers must design modern software interfaces specifically optimized for neural steering. Traditional menus must give way to context-aware environments that respond to cognitive user focus instantly. This alignment requires close collaboration between enterprise software architects and cognitive engineering professionals. Building these custom interfaces demands rigorous testing to ensure high compatibility with existing corporate production systems always. Accenture research highlights that future enterprise environments will be deeply collaborative and AI native. Integrating BCI technology accelerates this trend, transforming human executives into high-throughput orchestrators of automated corporate assets. The financial equation shifting from CapEx to OpEx becomes highly favorable over time. Once the initial hardware investment is complete, cloud-based neural decoding microservices operate on predictable consumption models. This economic efficiency increases when combined with tokenized corporate workflows and decentralized data processing. Enterprises optimize their compute footprints by routing neural commands through highly targeted micro-semantic models. Furthermore, employee onboarding protocols must adapt to include cognitive interface calibration sessions. Training neural networks to recognize an individual executive's unique brainwave patterns requires structured, highly optimized data pathways. Organizations must establish clear internal policies governing the wearability and usage duration of devices. Ensuring cognitive comfort and preventing mental fatigue are critical components of maintaining long-term workforce performance. The strategic objective is creating an environment where human intuition guides machine execution seamlessly. This integration eliminates the friction of manual data entry, unleashing true corporate automation capabilities completely. As systems scale, cross-departmental data pipelines must be fortified to handle cognitive telemetry securely. Data architects must integrate these unique streams into existing identity and access management solutions globally. This technical setup ensures that only authorized personnel can generate commands via neural pathways. Maintaining absolute control over execution privileges prevents unauthorized transactions or configuration changes within critical corporate ecosystems. The operational ROI is realized when critical incidents are resolved in a fraction of traditional times. Executives analyze systemic corporate issues and deploy corrective measures using purely cognitive steering mechanisms. However, collecting raw neural data opens an unprecedented vector for cyber and ethical risks. Let us analyze how to secure this sensitive perimeter against sophisticated infrastructure intrusions and internal vulnerabilities. Securing cognitive telemetry requires strict alignment with the NIST AI Risk Management Framework guidelines. Because neural activity reveals deep behavioral patterns, unauthorized telemetry exposure constitutes a catastrophic enterprise privacy breach. Threat modeling must account for unique vectors like neural signal manipulation or data interception. Adversaries attempting unauthorized access could exploit unencrypted neural telemetry streams to harvest sensitive corporate strategic insights. To counter these risks, organizations must enforce a comprehensive zero-trust architecture across all BCI endpoints. Every neural stream must be continuously authenticated, encrypted, and verified before executing corporate commands. Gartner cybersecurity research underscores that human-machine interfaces represent an expanding perimeter for sophisticated intrusions. Defending this perimeter requires deploying advanced behavioral analytics to detect anomalous cognitive command signatures immediately. For example, if an executive's neural telemetry exhibits unexpected deviations, the system must freeze access. This automated defense mechanism prevents credential exploitation or forced insider manipulation of critical operational assets. MITRE ATT&CK frameworks must expand to catalog techniques specific to neural decoding manipulation. Enterprise security operations centers require specialized playbooks to isolate compromised BCI hardware without disrupting broader network infrastructure. IBM X-Force Threat Intelligence indicates that identity and access management remains a primary vulnerability. Combining neural telemetry with multi-factor biometric authentication creates an extraordinarily resilient defensive barrier always. The ethical nightmare of recording employee brainwaves must be addressed through transparent governance policies. Human resource departments and legal teams must establish strict boundaries regarding data retention and utilization limits. Telemetry analysis must remain restricted entirely to functional system commands, avoiding any emotional or psychological profiling. Preserving employee trust is fundamental to the successful implementation of this advanced operational layer. By engineering robust defensive measures, corporations can confidently exploit the benefits of neural interfaces. Securing this biological perimeter ensures operational resilience while positioning the enterprise at the absolute technological vanguard. In summary, Brain-computer interfaces represent the next undeniable frontier of enterprise digital transformation. Moving from traditional physical inputs to direct cognitive steering maximizes corporate data processing velocity and execution efficiency. Leaders must act now to evaluate their organizational readiness for neural infrastructure integration. Developing a robust pilot program allows your enterprise to master the nuances of cognitive workflow orchestration safely. Balancing this extreme operational ROI with bulletproof zero-trust cybersecurity controls remains a critical mandate. Safeguarding your team's neural telemetry ensures sustainable innovation while maintaining absolute regulatory and ethical compliance. The future belongs to organizations that can seamlessly synthesize human intelligence with advanced algorithmic execution architectures. Position your enterprise at this competitive bleeding edge by adapting early and decisively now. The cognitive revolution is now completely reshaping modern corporate strategy and enterprise technological architecture across global industries. Subscribe to AI Knowledge is Power to lead the digital future.